Today we are going to be talking about inequalities in one triangle. So in our pictures we're going to have one triangle and we're going to talk about two different inequalities that we can use in these triangles. Our first theorem says if one side of a triangle is longer than a second side, then the angle opposite of the first side, that longer side, is larger than the angle opposite of the smaller side. So a picture for this, if I have three sides of a triangle that are of different length, or even it could be isosceles that two are the same, but in some way that they're not all three the same size, I'll mark them with 1, 2, and 3 according to the small, medium, and big sides. If you know how big the sides are in relationship to each other, then you can know how big the angles are in relationship to each other. Across from the biggest side is going to be the biggest angle. Across from the medium side will be the medium angle. And across from the smallest side will be the smallest angle. So if we can rank our sides by small, medium, large, then we can rank the angles by small, medium, large. Biggest across from biggest, smallest across from smallest. Theorem 6.3 is the converse of this. It says if one angle of a triangle. So it says the same thing but backwards. So the picture would end up being exactly the same once we mark it on up. But either way, if you know how big the sides are, you can rank the angles. If you know how big the angles are, then you can rank the sides. Okay? So that will be one type of problem that you will have today, is being given information about either sides or angles and asking to rank the other stuff. These corollaries come from those theorems. Remember, a corollary is like a middle ground between a postulate and a theorem, that a postulate can't be proven, a theorem can be proven. A corollary is kind of in the middle of that. We can prove it, but it's kind of just like a two-step proof because it follows so directly from a theorem, so we don't usually bother proving them. Corollary 1 says the perpendicular segment from a point to a line. So if I have a point and a line and I make a perpendicular, it says is the shortest segment from the point to the line. That's the quickest way to connect those. Because if I would connect the point to the line in any other way, it's going to be across from a 90-degree angle, which would have to be the biggest angle in a triangle. So that would have to be the bigger side, which would be bigger than just making the straight connection. Okay. The second one is the same thing, except it says from a point to a plane. So then we just make our picture into a plane instead of a line, and it says the same thing. So this is something that people say a lot in just everyday English. The shortest distance between 2 points is a straight line. The quickest way to get from the point to the line is to go there straight in a perpendicular way. And our last theorem for today is called our triangle inequality, and it tells us about numbers that can and cannot be sides of triangles. It says the sum, which means adding, the length of any two sides of a triangle is greater than the length of the third side. So in a picture, if I have A, B, and C, this triangle inequality says that if I add together any two sides, it should be bigger than the third side by itself. Technically it's any two sides, but in reality the only ones you really need to check are making sure that adding together the two smallest numbers will be bigger than the biggest number. Okay? So this tells us about numbers that can and cannot be sides of a triangle. For example, 1, 2, 3. If I had 3 sticks of length 1 inch, 2 inches, and 3 inches, I could not make a triangle out of those. Okay? Because 1 plus 2 is 3. And adding together 2 of them must be bigger than the third one to be able to make a triangle out of those. Okay? So adding together 2 numbers must be bigger than the third number if you're going to make a triangle out of those lengths. Okay? All right, so some examples for the different types of problems that you will have in your assignment. The first type of problem, you will be given a triangle with information about sides and asked to rank the angles. So in this picture, which angle is going to be the smallest angle?
Y.
How do you know?
Opposite.
Opposite of what?
Is that 29?
Smallest side.
The smallest side. So we find the smallest side, and across from that is the smallest angle. So 21 is the smallest number. Across from the 21 is y, so y is the smallest angle. What will be our medium angle then?
X.
X, because it's across from the medium side, which means the biggest one then has to be z, across from the
You have
biggest
to write
side.
it like that.
Yep. Some problems that might just say, which one is the biggest? So then you would just say the biggest, or which one's the smallest, you just say the smallest. But if it asks you to arrange them in order, then this is the way to do it. In some problems, you will be given information about angles. Don't trust your eyes. Pictures may not be drawn to scale. For example, this one is not drawn to scale. So if I want to give information about the sides here, I want to rank the sides in order, then I need to know the angles. We are only given 2 angles. You really need to know all 3 angles. Don't just trust your eyes and say this one looks like it's the smallest side. Okay? So I need to know what that third angle is. How can I find the third angle?
The angles inside of a triangle add up to 180.
They add up to 180. So I can add up what I have so far, and I get 153. And I know all together I should have 180. So I can subtract out and get that this angle must be 27. Okay. Once you know how big all of the angles in the triangle are, you can then rank them the same way we rank the sides. Across from the smallest angle will be the smallest side. So what's the smallest side? GH is the smallest side. Across from angle I is side GH. What will be the medium side?
I
HI or IH. Across from angle G, which means across from angle H is side GI, the biggest one. Another way to name sides of triangles is with a lowercase letter of the angle that it is opposite. So I could say that this side is I, this side is H, and this side is G using lowercase letters. Okay, and you may do that. So you could rank the sides and name them the way that we just did using the 2 letters and naming the segments. Or you could say across from angle I is little I, across from angle G is little g, and across from angle H is little h. And you can rank them that way as well. And that's a preference thing. You can either name the segments by the 2 vertices, or you can name it by the little letter that it's across from.
Can you do that whenever you're naming a triangle, no matter if
Yep.
you're working with this or not?
Yep, no matter what, that is how we can name sides of triangles. Is either by the 2 big letters that make that side, or by the little letter of the angle across from it. These theorems only work to compare sides in one single triangle. So in some of your problems, you're going to have pictures that have more than one triangle. So let's say I've got A, B, C, D, E. And I want to arrange A, B, C, D, E all in order, and there would be numbers filled in here to arrange them. So we would know how big some of these angles are. You can only work with one triangle at a time in these theorems. So what you would need to do is first look at one triangle and arrange the sides in that one triangle. And let's say, for example, it's A, B, C. Then you would look at the other triangle and arrange the sides in there. And let's say, for example, it's C, D, E. to get them all arranged in order, you would need to combine this information. So if C is the biggest one here and the smallest one here, I can smush that information together and say that all together then A, B, C, D, E. If it doesn't line up that nicely, there will be other information that you can use to help you in kind of sorting it out. So if the first one was like ACB, you know that stuff's gonna have to fit in there in the middle somewhere, okay? And there'd be other information you could use to help you figure that out. Okay? You can only use these inequalities in a single triangle at a time. You cannot use them to compare two triangles together. Tomorrow, we will learn some theorems to compare two triangles together. Okay. The other type of problem that you are going to have will use the triangle inequality theorem to say if numbers can or cannot be sides of triangles. So for example, 10, 9, 8. Our rule is that any two must add up to be bigger than the third. The only ones you really need to test are the smallest ones. So can these be a triangle?
Yeah.
Yes, because 9 plus 8 is 17, which is bigger than 10. So you want to add up two of the numbers and make sure that it's bigger than the other number. Okay. How about 7, 7, 20? Why not?
Because 7 plus 7 only equals
7 plus 7 only equals 14. So that doesn't work. If I would think about taking some sticks with these links and trying to connect them, it's just that there isn't enough length there to be able to connect and close it up. Okay? Even if I laid them down flat, even if I took those lengths of 7 and laid them down flat, they still wouldn't even touch. Because I would have an empty space of 6 in between them. Okay, I can't even make them all fit in a line together.
So if you had like a 10 and a 10, would that be?
So, good question. Let's say I had 10, 10, and 20.
No.
Can I make a triangle there?
No.
Not quite. So why am I writing yes? The inequality theorem is just strictly a greater than. It is not a greater than or equal to. Because again, if I tried to take some sticks and laid them out and I got a 20, and I have a stick of length 10, and I have another one of length 10, they fit together and make a line, but if I try to open them up at all and make a triangle out of it, they're going to start gapping apart there in the middle as I hinge those corners. It won't close up anymore. So it has to be that if I would lay the two smaller ones, that there's some sort of an overlap there so that when I open it up, they'll be able to meet. Okay? So to figure this out, you add up the two smaller ones, make sure it's bigger than the biggest one. In your assignment, some of the problems are going to say, given two numbers, what are some boundaries on what that third side could be? So first, let's assume these are the two biggest sides. What would a boundary then be for that smallest side?
4.
Sides can have decimal length.
Ooh, 3.1. Well, 3.1.
3.1, it could be even smaller, 3.05, 3.01. The thing is, it has to be bigger than 3. Okay? So if I had a 3, a 6, and a 9, it wouldn't work. But if this was at least a little bit bigger than 3, that would add up to more than 9 and it would work. So 3 is my boundary. It can't be 3, but just a little bit bigger than 3 would be enough. Now let's say these were my two smallest sides. What would the boundary be on the biggest side then?
Smaller than 15.
Smaller than 15. Okay? If I add these up, I get 15. And so that other one can't be any bigger than 15. Okay? It also can't be 15. We don't want equal to's here. So to find our two boundaries, we subtract our numbers to find the lower boundary and add them to find the upper boundary. Okay?
We'll put negative numbers.
We're not going to talk about triangles with negative side length until we talk about trigonometry later.
Yeah, like C.
Wait, there's actually such thing
Later, like January.
No.
So, Alright.
About trigonometry and geometry.
Your assignment is from 6.4, 1 to 17. They are all problems, no proofs. Can you